Alright, so good evening, all of you. So today I will start with one very important topic from ninth class, right? Which is generally asked in the exams, right? So we will see that, okay? And what is that? It's a midpoint theorem, right? So let us begin with that, okay? So the midpoint theorem, what it says that mid, midpoint theorem. Okay, theorem. What it says that, as you can see, the midpoint. It says that if a triangle, okay, if a triangle is something like this given, and let us name it as A, B, C, right? And there is what? E and F is given as a midpoint, right? Means you can see that given is what? E and F is the midpoint of AB and AC, right? This is what given, okay? And we can construct something. What we can do is we can join E and F and extend extend to a point, you can say D, okay? So it is something like we can join it like this, okay? And then you can do it like this, okay? And you can join it over here. You can extend it till D, right? Alright? And you can say that we have drawn a, you can say G, okay? So you can say that by construction we have what? AB parallel to CG, right? We have drawn this line in such a way that AB is what? Parallel to CG. Alright? Thank you. Now, so what we have to do is you have to prove that what? The EF is parallel to the third side, which is BC. And second proof is what? You have to prove that EF is half of BC. Okay. So this is the two proof we have to do. Okay. If these two conditions satisfy, so we can say that it's a midpoint theorem, right? Means statement of midpoint theorem is what? The line segment, the line segment joining the midpoints of two adjacent side is parallel to the third side and half of the third side. This is what the midpoint theorem says that. Okay. So let us begin with the proof. So in proof what we can write it as, okay. So we'll do this in 3 steps, okay. So first one, what we will prove is this triangle, we will make it congruent, right? And then we will prove it that if this side is equal or not, right? And then we will prove this is a parallelogram or not. If this is a parallelogram, so we can say that this side is equal to this and this side is equal to this. And then after in the third one, we will prove this, that since this is parallel to this, then this must be parallel to this and this must be half of this also. So we'll see that how. Okay. So moving on next, the proof. So let us assume what? Let us assume the triangle first. So it is what? The triangle something like this. Okay. Is it visible to you? Yes. All right. So A, E, F, C, and D. Right. Since we have drawn this line as like this is parallel to this by construction only, right? So we can say that what we'll say that to this, we'll prove this also if it is parallel to or not, because since this is parallel to this given here, okay, but this is parallel to this we don't know, right? So we'll see that, okay. Since you know that this is what the vertically opposite angle, so let us mark it. You can write it as angle 1 equals to angle 2, right? It's a vertically opposite angle. Fine, I'm writing it so, but you have to write in full, okay? Now, also you can write as what? AF. AF is equals FC. Can we write this? AF equals to FC. Why? Because F is the midpoint, right? Now, similarly, we can also write that what? This side is equal to this. The 3 equals to 4. Sorry. Okay, we can write angle 3 equals to angle 4. Why so? Because since AB is parallel to CG, right? Right? AB is parallel to CG, and by this we can also say that AE is, okay, let's forget it. AB is parallel to CG and AC is a transversal line. Transversal line. Okay. That is the reason why we can say that angle 3 equals to angle 4. That is nothing but alternate interior angle. Clear with this? Right? So by this three condition, okay, we can say that triangle AEF is congruent to triangle CFD by ASA. Okay, just note it down. So we'll move to the second step. Okay, just have a look. Okay, so since we have already proved that triangle AEF is congruent to triangle CFD, CFD, right? We have proved it by what? ASA. Then we can say that what? We can say that AE equals to CD also, right? We can say that angle AEF equals to angle CDF also. CDF. And also we can say that what EF equals to DF. Okay. These three information we get from congruency of these two triangles, right? So we'll see how we can use it, right? Alright. Now moving on next, we have to prove what the second step is what? You have to prove that this is what? A parallelogram. You have to prove that EBCD is a parallelogram, right? So we'll see how. Okay. All right. Okay. G. Okay. Since, if you say it, since we have done it like AB is parallel to what you can say CD, right? And also we have proved that AE parallel to CD also we can write, and AE equals to CD also. Just mark it one. Okay. Now, also one thing you can write as what AE equals to EB also, right? This is equation second, right? So from 1 and 2, can we write it as EB equals to CD also? We can write this EB equals to CD, right? Since we have done it, okay? Since we know that AB is parallel to GC, so we can also write as what EB parallel to CD, right? And similarly, we can also write as ED parallel to BC, right? So we can say that what EBCD is a parallelogram, okay? And if so, now moving on, third step is what? If ED is parallel to BC, because EBCD is a parallelogram we have proved over here, right? So from here we can say that, see, ED is ED. Where is ED? ED is parallel to this. Okay. Now, if it is so, so we can say that what EF is also parallel to BC, right? And this is what the first first proofs are. Okay? This is what we have to prove. EF is parallel to BC. Done. The next one is what? This is half. Okay. How we can do? Since we have done what? EF equals to f ef equal to df, right? Here, right? So from here we can also write as what ef is half of ed also, right? We can write this. Okay. Similarly, if we write this, so we can also say that since ed, what we can write this also as what ed is equals to bc also, since what since EDBC is a parallelogram. We have proved it, right? Since ED equals to BC, so from here we can also write as what EF is half of ED. So we can say that EF equals to half of BC also, right? Why? Because BC equals to ED, right? That's it. This is what you have to prove. The midpoint theorem. Okay, good. Okay, so thank you so much. Okay, just have a look carefully, and if you have any doubts, just write in the chat box. Okay, and in the next class, more probably, we can discuss that doubts. Okay, so just you can note down. Okay, and if you like it, please subscribe my channel and press the bell button also, so that you can get the new videos from my side. Okay, thank you so much.